Welcome back to Djji Tutorials. Let's talk about the graphs of quadratic functions. A quadratic function is a polynomial function where the highest power of the variable is 2, expressed in the form f of x equals ax squared plus bx plus c, with a not equal to 0. The graph of a quadratic function is a parabola, which is a U-shaped curve. Key characteristics and concepts. First, the general form f of x equals ax squared plus bx plus c, where a, b, and c are constants, and a is not equal to 0. Next, the parabola. The graph of a quadratic function is a parabola, which can either open upwards when a is positive, or downwards when a is negative. The vertex is the turning point of the parabola, and it can be either a minimum for upwards opening parabolas, or a maximum for downwards opening parabolas. The axis of symmetry is a vertical line that passes through the vertex, dividing the parabola into two symmetrical halves. The roots, zeros, or x-intercepts are the points where the parabola intersects the x-axis, representing solutions to the quadratic equation f of x equals 0. Finally, the y-intercept is the point where the parabola intersects the y-axis, which is found by evaluating f of 0. Alright, let's talk about the standard form of a quadratic function. It's written as f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. So, a, b, and c are called coefficients. These are constant values that actually determine the shape, direction, and position of the parabola, which is just the graph of a quadratic function. The x squared part is known as the quadratic term, and this term represents the variable squared, which is, the defining characteristic of a quadratic function. The bx part is called the linear term, and it's simply a multiple of the variable x. Then there's c, the constant term, which doesn't have any variable at all and represents the y-intercept of the graph. And remember, a cannot be 0. If it were, the function would just become linear and not quadratic anymore. Now, let's look at what we call the square form of a quadratic function, which is also known as the vertex form. This is a really handy way to write a quadratic function because it makes it super easy to spot the vertex or the turning point of the parabola. The square form is written like this: f of x equals a times the quantity x minus h squared plus k. Here, a is the leading coefficient, and it determines the direction and the stretch of the parabola. The point hk is the vertex of the parabola. Specifically, h is the x-coordinate of the vertex, and k is the y-coordinate. And finally, the part x minus h squared is the squared term that actually gives the square form its name. So why is the vertex form, or square form, so useful? Well, first, it makes identifying the vertex a breeze. The vertex form immediately shows you the vertex of the parabola as the point hk, which is super helpful for graphing and understanding how the function behaves. Also, when you're solving quadratic equations, knowing the vertex form lets you solve them by completing the square, which transforms the equation into something that's much easier to solve by taking the square root of both sides. And the vertex form is really helpful for visualizing and performing transformations, like translations, stretches, and reflections on quadratic functions. Thank you for watching this video. See you in our next session.